All right, here comes numbers 7 through 12. And so in this problem, we have our explanatory variable IQ, seeing if the IQ is a predictor of music aptitude. All right, so I identified our things here, our sample slope, our standard deviation of the slope. The first one, we are asked to actually find that t statistic. So for the null hypothesis, so remember, we can compute that by hand. So find this t-test statistic. It's the sample slope minus the hypothesized slope, which they tell us is 0, over that standard deviation of the slope. Fill it in, and you have 4.05. So then we could get that p-value, of course, by TCDFing that out to infinity. They didn't ask us for that right now. So here we go. 99% confidence interval. Okay, so I can tell a key, here's our sample slope, our little b, plus or minus critical value. That's probably going to be the key to doing this problem here. And so I can see that we are inverse t of one tail with 18 degrees of freedom. I guess we had been told there were, yes, 20 individuals. So our sample size is 20, our degrees of freedom, 18. Now notice that here's a common mistake. Don't inverse t 0.05. That would be 90% confidence. If we have 99% in the middle, then that's putting 0.005 in a tail. All right, so that gave us then our answer there. It was 2.878. So there we have E. Next, interpretation of the slope. For every one increase in the X, which is IQ point, the predicted Y, so the music aptitude score is predicted to increase this many points. All right, so that was C and number 10, true or false, okay? So let's see. It says the significant test for slope of a regression line is always, that's always a um, flashing light, a warning. It's saying always or never. You really want to investigate that on a true false, especially. So based on the hypothesis with the null being 0 versus alternative not equal 0. Okay, we saw that on a previous problem already. That is not true because you can investigate positive slopes versus negative slopes as well. All right, number 10. Oh, I guess that was 10. That was 10. So number 11. So when I'm reading this, I can tell here that we are, it looks as though we're getting just one sample of voters, and then we're categorizing them based on two variables. Their political party affiliation was also recorded, in addition to their support of the healthcare reform cost per taxpayer increase. Okay, so just FYI, that was a chi-squared test of independence. We were testing it at this alpha level. So, the p-value, sorry, the p-value is 0.001. So what does that mean? So, of course, I am, kind of thinking in my mind, what's the null and what's the alternative? So let's take a look at that. So the null hypothesis for a test such as this would be that the two variables, null is saying those two variables, nothing to do with each other. They are independent of each other. They are not related. There is no association. Okay? So you want to get that language. They are independent of each other. There is no association. That's what the null hypothesis would say about the variables. With alternative, the opposite. Okay, the alternative says, yeah, something's going on. Yes, definitely. The support for that is related to your political preference. Okay, so what happened with a p-value of 0.001? Well, I'm thinking that p-value is low. So I'm going to reject HO and conclude then that I have evidence that the two variables are not independent and that they are related, that there is an association. So they are not independent of each other. In other words, knowing their political preference does give us insight into their support of the healthcare increase. All right. Here we were just asking what type of inference is appropriate for this situation. Well, I can see that it looks like I have paired data. Looks like I'm collecting something about both a husband and a wife. So that's kind of making me already think about one particular type of inference, matched pairs. Let's see, this is seeing if, on average, what's the difference between the height? Men, let's see, could be used to determine if, on average, men are taller than women. So, on average, what's the difference in their height? So, that one difference of the paired data is the type of inference that I would run. All right, that's your numbers 7 through 12. The next video is going to be your numbers 13 through 20.